This is the second day on Chapter 8, Section 3, titled Volume of a Sphere, and these are dealing with composite figures. So composite figures involves more than one figure, and here we've got a hemisphere on top of a cylinder. And so it says a hemisphere is 1/2 of a sphere. The top of the silo is a hemisphere with a radius of 12 feet. What is the volume of the silos? That includes the hemisphere and it includes the cylinder. We're supposed to round to the nearest thousand. So this is to the thousands place, not the thousandths place. So we have no numbers after to the right of the decimal. And so it says the silo is made up of a cylinder and a hemisphere. It tells us that. And so what we're going to end up doing is when we've got one of these composite figures, we're breaking it into figures that we know the volumes for. And so here I know a volume of a cylinder is pi r squared times by the height. And I'm going to add on the volume of a hemisphere. So a hemisphere is half a sphere. And so what that means is I need to take half of my sphere formula. So half of 4/3 pi r cubed. And so now I'm going to substitute my numbers in there. So I know that the radius to the cylinder is 12 feet, so 12 squared times by the height of 40. And so over here, I've got half of 4/3. Well, 2 goes into 4 2 times. So really, I've just got 2/3 I need to take of pi times the radius, 12 cubed. And so now I'm going to go ahead and use the calculator to come up with some of these numbers here. So I've got to multiply 12 squared times by, and then 40. And that's going to give me 5,760 pi. So 5,760 pi. Now notice I'm not multiplying by pi yet. And the reason is because I can add this other term with respect to that is in terms of pi as well, and it'll make it easier. So now I need to go ahead and take 12 and bring that to the third power. So I cubed it. So right here I cubed it, and then I'm going to multiply by 2 because that's what I do with the numerator of the fraction. So I multiply by 2, and then I divide that answer by 3, and that's going to give me 1,152 pi. So you see, I've relieved these in terms of pi because now I can add these two numbers together. So I take 1152 and I add on 5,760, and that gives me 6,912 pi. So now I can go ahead and take that answer there and multiply it by pi, and that gives me this number here. So it's going to be about, and then it was 21,714, and that decimal point kept on going on and on and on. But we're rounding to the thousands place, to the nearest thousand. Well, this is the thousands place, so I need to look at the 7, and it's big enough to round that up. So I'm going to round it to 22,000, and these are cubic feet. That's the capacity of this silo. So that's what we're going to do on these problems. Let's take a look at a couple other examples here. This is a little different because now we have a cone and a cylinder. And so I'm going to find the volume of the cylinder, and I'm going to add it to the volume of the cone. And so the cylinder is pi r squared times h. So pi r squared times h. And the volume of a cone is 1/3 pi r squared times by its height. And so I'm going to go ahead and substitute my numbers in there. The radius of the cylinder is 3 squared, or 3, so I'm going to square that number. And then I'm going to multiply the height by the height, which is 9 centimeters. And then for the cone, it's 1/3 pi, and the radius is the same as the cylinders, so 3 squared, but times by a different height. It's 5 meters. And so I go ahead and multiply out. So this makes 9 times 9 makes 81 pi. And on this side, this makes 9, but 1/3 of 9 is 3. And 3 times 5 makes 15. So 15 pi is what I get on this other side. And so I go ahead and multiply, and I end up with, or adding these two numbers together, gives me, and let's go ahead and add these two. So I got 81 plus 15. And the reason I'm adding them so I can go ahead and write that number on the calculator. And I've got 96. So 96 pi is what I get when I combine those two terms. Now I'm going to take that number and I'm going to multiply it by pi. And that gives me this number here, 301. So 301.59. So I'm going to round to the tenths place here. So that's going to be 301 6/10 because that 9 was big enough to round the 5 up. And these are in meters, so meters to the third power. So taking a look at this next problem here, I'm going to go ahead and when I read it, it talks about a cylindrical container has 3 rubber balls, has a height of 18 centimeters. So the height from the top to the bottom is 18 centimeters, and the diameter is 6. So all the way across is 6 centimeters. Each ball in the container has a radius of 3 centimeters. So that's the same as the radius of the cylinder, so it just barely fits in there, just fits. Find the amount of space that the container, find the amount of space in the container that is not occupied, so not occupied by the rubber balls. Okay, so what we're going to end up doing is we're going to find the volume of the cylinder, and then we're going to subtract. This time we're going to subtract the volume of the 3 spheres, because we want to find the space that is not contained by the rubber balls, and so the air space in here. So the volume of the cylinder is going to be pi r squared times by height minus 3 times by 4/3 pi r cubed. And so in this case, I go ahead and substitute my numbers in there. Pi times the radius, which is 3, because that was the diameter, so we need to cut that in half, times by 18. And then minus, now here these 3's are going to cross out, they're going to cross cancel, so I'm just left with 4 now. 4 pi times by the radius, which is 3 to the third power. So multiplying these numbers, I end up getting, so let's pull that calculator up here, so I end up getting 9 when I do 3 squared, so 3 squared times by 18, and so that gives me 162 pi. And then I'm going to subtract, and this makes 27 times by 4. So again, I got the 27 by doing 3 cubed times by 4. That gives me 108 pi. And so now I'll go ahead and subtract these two numbers. So I'll do 162 minus 108, and that gives me 54. So 54 pi. And so we get 54 pi, and then we're going to take that number and multiply it by pi, and I end up getting this, 169.6. The 4 is not big enough to round that up. So 169.6 was our answer. So this is in the units here. Let's see here. We are in centimeters. So centimeters to the third power, cubic centimeters. And so that's the airspace inside. So those are the types of problems that you're going to end up seeing on today's assignment. Good luck.